This week on the Computer Chronicles, how to build the ultimate gaming computer. We'll talk graphics cards and show you the new NVIDIA GeForce 3. We'll talk sound cards and show you how to add stunning theater-style surround sound to your games. We'll show you what it looks like to play a game on the newest Pentium 4 chip, running at a blazing 1.7 gigahertz. And the editors of Maximum PC Magazine will show us their choice for the best overall gaming computer. How to build the ultimate gaming PC, coming up next on the Computer Chronicles. Computer Chronicles is made possible in part by PC to PC, the online computer migration service from PC First, moving files, applications, and preferences from your old computer to your new one. Additional support is provided by Upside Events, presenting the Digital Lifestyle Revolution Conference, where people and technology intersect. Hi, and welcome to the Computer Chronicles. I'm Stuart Chaffee. There's some very interesting marketing data on new PC purchases, which shows that most PC upgrades for consumers are driven not by the grown-ups in the house, but by the kids who want a more powerful gaming machine. Certainly there is no more demanding application for a computer than today's graphics-intensive games. So today we are going to help you figure out how to put together the ultimate gaming computer. And we're going to start out with graphics. And here to help us do that is Tony Tomasi of NVIDIA. Hi, Tony.
Hi.
All right, so you've got the brand new GeForce 3 graphics card here. And there's a million cards out there. This is new. What is different, better? It's actually a next generation card.
That's exactly right. The GeForce 3 is the latest generation graphics processor from NVIDIA. So this product actually includes a 57 million transistor graphics processor. To put that in perspective, that's more transistors than a Pentium 4 plus a Pentium 3 put together.
Just on the graphics card?
Just on the graphics processor,
okay.
As well as 64 megabytes of 230 megahertz DDR memory.
But what's key about this is it's programmable,
That's exactly right. For the first time, the graphics processor is as programmable as the CPU. We have an instruction set. Just like the Intel processors have an instruction set that you can program Microsoft Word or Windows with, we now have an instruction set that game programmers can program to create special effects on our processor.
So that means a game developer is not stuck saying, oh, I can only do what the graphics card will let me do. You can make the graphics card do whatever you want it to do.
That's exactly right. So for the first time, really, in real time, game developers can create essentially special effects.
Yeah.
And so what used to be the domain just of movies and special effects there, which are render farms and it would take hours per frame, we render those same special effects in real time at 60 frames per second.
This is all about what's on the screen. So let's get to the computer here, and I want you to show me a couple examples. First of all, in a game, I mean, you're concerned about the surfaces of things, the texture, the animation. Show us an example. You have a great example, I think, of a chameleon there.
Right. So we came up with this idea of the chameleon to really show off the nature that because it's programmable, it can change the way it looks. And so interactively, we can actually demonstrate programmability with this chameleon here. So it's completely real time. I can look at it from any camera angle, any way that I want. It's actually being driven.
So this is all being generated and driven right now in real time.
That's exactly right. All this
code responding to your direction
is running on the graphics processor in real time.
Okay. So you've wireframed it, for example?
The first thing, of course, is that the chameleon is built from geometry or wireframe. The animation of this chameleon, how he moves and walks and the skin bends over him, is done with a program. We call that a vertex shader. That's a piece of code that runs on our graphics processor that drives the way he animates. In addition to that, of course, we have the way that he looks. And so we have a variety of what we call pixel shaders to generate special effects that are on the surface of this creature. And so interactively, we can create essentially the Predator look, where he's actually semi-transparent. He actually refracts the ambient light around him and yet still reflects it, or bends it into the environment. And again,
to be clear, this is no cutscene here. I mean, this is, you are running this baby.
That's right. If you look at my hand and you
you
look at the mouse as I move it around, it's completely interactive. We can play with this as we see fit. And if you look at, well, this is actually our Invisible Man shader to kind of give you an idea what the skeletal system and the vein system look like. We'll go ahead and let the chameleon continue walking here, and we'll talk about some of the shaders. So as we get close, we'll go ahead and zoom in on the surface of this guy. And if you look, just say on the joints of his arm there, the bumps are correct. The way the specular highlights move across the bumps as he animates are all completely correct.
All right. Now, I want you to go to the next demonstration. Another thing in a game is the landscape, the background, the environment. They're often sort of clunky and dull, and they don't really get you into the game emotionally. And you have the ability now to actually generate real-time landscapes too, right?
That's exactly right. Because the processor is programmable, we can actually program the processor to procedurally generate a world. So the advantage here is that where previously worlds would have an end. You could get to the end of the texture or the end of the geometry, and that was it.
So again, this is a real-time generation of this landscape.
Right. If you notice the mouse as I pan it towards the edge of the screen, that's the direction that I fly, and I'm flying around the world. I can get close to the landscape. I can fly up in the air. The other nice thing about this, the world is completely generated, but we've got so much graphics processing power that we can actually have a little bit of fun. So wherever I click on the screen, we have a meteor come flying down, and the meteor does some interesting things. As he clicks and lands, you notice there's that ripple, that shockwave. Yep. We do that with a vertex shader. It's actually taking the geometry underneath and deforming it.
And again, you're running this right now. It's
on the graphics processor.
Not just happening.
That's
the last thing
time.
I want you to show us is the hardest thing in a game is the human face, right?
That's exactly right.
There's so much subtlety in the different expressions. Most games, the faces are pretty boring. You never get to know them, right? You have a demonstration here, which is just incredible, on what you can do with this card.
Yes, we wanted to solve the problem, or at least attack the problem of creating some emotional conveyance in a character. Today's game characters are kind of blockheads. They have flat faces, maybe moving textures, and typically plastic hair.
So what do we have here? Zoltar.
So we've got Zoltar, which is actually kind of modeled after the Zoltar character from Tom Hanks' movie Biggs. He's a fortune teller, and it's a completely interactive face. I can view him in wireframe. Or not.
Yeah, but go back. Let's see the motion around his. When he talks, I mean, you can see the skin stretch.
We'll move into his face a little bit here.
Mouth,
get nice and close, and we'll go ahead and fire up an animation here. And you notice that what we can do is program the graphics processor to deform his actual skin. We've modeled the skeletal structure and the muscular structure of his face as programs. We download those to our graphics processor, and we can animate him and move him around entirely in real time. So for the first time in real time, you can get human characters. This is something that even the movie industry has really just started trying to tackle, and now we're running it in real time on a graphics processor.
Okay, so it's NVIDIA's GeForce 3, and it'll cost me how much?
About $399.
All right, thanks a lot.
Great, thanks a lot, Stuart.
All right, well, once you have a killer graphics card in your computer, the next most important element for a great gaming machine is sound. There are many sound cards and systems out there to choose from. Here to tell us about one high-end option is Scott McNeese of Philips. How you doing, Scott?
Great.
Okay, now we have to explain, it's pretty hard to demonstrate this on television because most people are listening to some little monaural clunky speaker on a TV set probably. So they're going to have to trust us a little bit.
Right.
So let's talk about what's the big deal about your new sound card, which is what, the acoustic Edge. Okay.
Yes.
It's a new generation card too. Why?
Yes. Well, basically what we set out to do is when you're in, how great it is if you're sitting in a movie theater with really nice Dolby Digital or DTS sound system, and you're surrounded by sound, so you just really, really get immersed in it and enjoy it. Well, we want to be able to create that same experience on the PC. The problem on the PC is most of the sounds you hear, music, even most of the sounds in games, are not positional or not 3D.
At best, it's just stereo sound, right?
Exactly. So we came up with a solution in terms of our Thunderbird Avenger chip that we developed and the algorithms that we put on it that basically allow us to take any stereo sound and create multi-channel sound, that is 4 or 5.1 channels of sound, just like in the theater, so it surrounds you.
So even though the game itself is only pushing, say, stereo sound, 2-track sound, you can somehow put an algorithm on top of that and pull that apart into 5 different channels, so I really have surround sound.
Exactly. In fact, there's 2 different cases there. There's some games that have no positional sounds at all, and those will make that game all of a sudden a positional 3D or a surround sound game. But even those games that are coming out now that do use positional 3D, they'll only take a portion of the sounds and actually position them, and everything else will be stereo or mono.
So you can actually put more in the game than was in there in the first place, this algorithm.
Additional layers of surround sound, if you will.
You have a nice little demonstration here, actually. If you can show us a sort of visual representation of the way you break up the sound. Yes,
this is an MP3 player that's included, and there's going to be a visual here. I'm going to start it up, and first actually we're going to start it in stereo, and you see these 2 little visuals here. That corresponds to a left and right speaker.
Okay, so that's the 2 tracks that are sort of pushing out the sound right now.
Right, exactly. Now, I'm going to go to
that would be our typical stereo environment.
Exactly. Now I've gone to 4 speakers, and this shows...
Now, how did you go to 4 speakers? You just told your card I want 4.
Exactly. I said, let's assume we have a 4-speaker setup with this, and let's go to 4. And if you look at this, you can see the 2 front left and right, and the left rear and right rear are very different signals, and you can actually hear it. So all of a sudden, you're hearing different sounds from every speaker. Now we're going to take it a step further. Let's say you have a